Yeah, good evening, students. Hope I'm audible to all of you. Okay, so today we are starting on with a new chapter, work, energy, and power. So, which also plays a very important role for your competitive exams. In fact, work, energy, and power, and ನಮ್ಮ previous part of chapter that also, which is the laws of motion, motion in a plane, motion in a straight line. We have covered so many concepts so far and so many chapters. So today is also one such chapter which plays a pivotal role for your competitive
Manish,
point
one
of view.
request, Manish, to the
Ah,
extent possible, to speak in English. I think one
English.
or
Okay.
two that Maharashtra boys may come.
Okay. Okay.
Maybe
I
they
was,
could.
planning to mix and match both English and Tamil.
But Tamil, I
Okay, fine.
think in the class, because one or two people may
So all
come.
of them are comfortable with English, then it's fine.
Yeah, yeah,
Well and
English
good.
they are comfortable. Everybody is comfortable
Okay,
with English.
okay, everybody is comfortable. All right. Okay, children. Okay, sir. So we'll continue. So planning to do today work and work, energy, and power. So that is the chapter that I've planned for the day. So we'll see the basic concepts, and then eventually we will solve the previous year questions from NEET and JE, which is appeared. So on that note, we'll start. And children, just please confirm if you're able to see that what I'm annotating. And my humble request would be, instead of just putting something on comment, I would recommend you guys to feel free to unmute and speak, so that we have a two-way communication, which is much better. So that is my humble request from all the students. So let us try to communicate as much as possible, and try to ask questions. The more questions you ask, your database of knowledge will definitely improve. Okay, so that is one thing which I would like to add. So on that note, we will start. And somewhere you're stuck, you're free to anytime ask. So we are here to help you out. Okay, that is our intention. All right. So we'll begin. Please confirm, children. Any one of you can confirm that you're able to see what I'm writing on the screen. Okay, there might be a small delay, but you should be able to see.
Audio is little weak.
Okay, audio is
Come
weak.
closer to
Okay,
the mic.
I will increase the audio. Now is it better?
Yeah, yeah, now it's better.
Now it's better. Okay. So children, I'm annotating on the screen, which means I'm writing. I hope you're able to see. I'm writing the chapter's name.
Yes, yes, we are able to see.
Okay, okay, uncle. Thank you. Fine. So today's chapter is work, energy, and power. So we'll try to understand what are the basic concepts of work. What do you mean by work? When do you say work is said to be done? All right. So in physics, we say work is done when force is applied on an object and the object moves by certain distance. So then we say work is done. But what if I'm applying force and the object does not move, but I'm still wasting energy? So do I say work is done or work is not done when force is applied and the object does not move? Anybody?
Energy is consumed, but work is not done.
Work is not done. That's correct. Absolutely right. So in physics, work is done when force is applied and the object moves through a distance or through some displacement. So that is the technical definition of what is work done. Okay. So on that note, children, we will continue. So work done can be written as the product of force and distance. Now here, I hope you guys would be knowing force has the unit Newton and displacement has the unit meters. So what is the combined unit of work done? Combining force and displacement, we can say the unit of work done as Newton meter, but can be replaced with a standard unit called joules. Okay. So joules is the standard unit of work done. So this is the idea. So when can I say that work done is 1 joule? So I can say work done can be 1 joule when 1 Newton of force is applied on an object to move it through a displacement of 1 meters. Then we can say that work done is 1 joule. As simple as that. Now, is it necessary that all the time force has to be 1 Newton and displacement has to be 1 Newton, 1 meter? Not necessarily. It depends on the situation and circumstances. Your force can also be 2 Newtons and your displacement can be zero point 0.5 meters, and still I end up getting 1 joule, isn't it? So this is also possible. So there are different possibilities. So work done can be 1 joule if 1 newton of force acts on an object to displace it through 1 meters, or 2 newtons of force acts by to displace it by half a meter. Okay, anyways it can work. All right, so that's all about work done, the formula of work done. Now, work done can be positive, it can be negative, or it can also be zero. Okay, so I'm writing that here. Work done can be positive, or it can be negative, or it can also be zero. It depends on the situation and circumstances. So that's all about it. So that's the basic idea of work done. Okay, the simple definition. I mean, simple concept of what work done is all about. So with that, we'll move on to the next concept. Now we'll see what is work done when you're trying to push or pull an object through an angle. I repeat, work done by an angular force. Okay, so we'll see that. What is the work done by an angular force? Now, what do I mean by an angular force? So, force is not applied straight or linearly. Rather, force is being applied angularly. That means at an angle to the horizontal or to the vertical. Then, what would be the work done? So, that is what we are trying to understand here. Okay, our understanding here in this particular concept is that work is being done by applying a force at an angle to the horizontal or to the vertical plane. So then let us see how to understand the concept of work done. So I'll give you an example here to demonstrate so that you can understand the concepts much clearly. So here there is a lawn mower. Okay, I repeat, we have a lawn mower. I hope you guys would have heard about this term lawn mower. It is used to level the lawn. Okay, it's also used in a playground, or you can say where cricket match is going to be held. Lawn mowers are typically used to make the surfaces plain. Okay, if it's uneven, to make it even, lawn mowers are typically used. A common term which we all know is the road rollers. I hope you guys know that's used to make the level of the road even or plain. Similarly, a lawn mower is also one such instrument which is used to make the lawn straight. Here, to this lawn mower, there is a lever which has been attached, and force is applied like this. So let me call the force as F. Okay, F is the amount of force applied at an angle as shown. So here we are applying force on the lawn mower at an angle theta as shown in the figure. Now the question is, what is the work done in moving the lawn mower from point A to point B? The distance between A to B, say it is going to be, let me call it as 5 meters, and say we are applying a force of, let us say, 15 newtons. Okay. Now the question is, what is the work done? How can we answer this question? We have a lawnmower that is being moved from point A to B to a distance of 5 meters from the initial point. And what is the work done? Here, the general formula force into displacement will not work. Why? Because your force is not linear, it is angular. So you will have to resolve this into component. So find out the component of force along AB, because AB is linear. So what is its component here along this line? So it is the x component. Anybody, any guesses? What will be Fx, which is nothing but the horizontal component of force? It's along the x plane or the x, direction, x axis. It's making an angle of theta. You resolve force vector into the horizontal component. So fx is equal to f cos theta. Now you go and substitute on what's your answer. You will get f is nothing but 15. So 15 cos. Now let us take theta as 30 degrees. Okay. So I go and substitute the value of theta as 15 cos 30 degrees. And what's the answer? What is cos 30? Anybody? I hope you must be knowing trigonometry. Yes, children. Anybody? Feel free to answer. I hope it's root 3 by 2 or 1 by 2. It's root 3 upon 2. Okay. So you substitute, you'll get 15 times cos 30, which is root 3 upon 2. Okay. You can cancel out 15 by 2. Can be written as, I hope, 7.5. So you can say it's 7.5 root 3 newtons. Okay. That is your horizontal component of force. Okay. So now you go and substitute in your formula, work done is equal to force into displacement. Now you see I've substituted in the place of force as F cos theta into S. So what is F cos theta? We have calculated the answer as 7.5 newtons, 7.5 root 3 Newton into displacement. We are moving it to a displacement of 5 meters. So what is the answer? It is 7.5 multiplied by 5. So you just need to multiply it with 5. And how much do you get? 5 5s are 25. Carry over, I guess 37.5 is what you will be getting. So you get the answer as 37.5 root 3 joules. Root 3 value, you will have to substitute, children. I hope you guys know the value of root 3. It's 1.732. Okay, we can take it as 1.73. So 37.5 times root 3 would give you 64.8 joules. And that's your final answer. So I hope this part is clear to all of you. This is how you will calculate the work done in case of an angular force, okay, which is 64.8 joules. Okay, this is very important. The concept is important. So based on this concept, you have so many varieties of questions that can come. What I have discussed here is a simple one. Okay, we definitely have complicated versions of this. Okay, I'll teach you all the versions. This is one such version. Okay, now we'll see another situation. I'm giving you another situation. Example 2. That was example 1. Let us consider this as example 2. Work done. Okay, work done in lifting an object work done in lifting an object along an inclined plane. Okay, so we are going to understand how to identify and how to calculate the work done in lifting an object along an inclined plane. Inclined plane is basically a ramp. So when force is applied along the inclined plane, and how you're going to, calculate or evaluate what is the work done. Okay, so let us see. So let us draw an inclined plane here. So here, this is an inclined plane. So I'm giving you the angle of inclination, that is theta, which you can take it as 60 degrees. Okay. So we have a block, children, here, which is placed at this tip A. Okay. So it is moved from that point to another point, say B, this tip B. The distance from A to B is not given as of now. You will have to calculate that. Okay. So I'm giving you the sides. ABC is basically a right angle triangle. This is 3 and this is 4. Okay. I hope now you can calculate what is AB. By using Pythagorean rule, you can get AB as 5, right? Under root of 3 squared plus 4 squared, which is root 25, you get 5. So AB is now 5. So this is 5 meters. Question is what is the work done in moving the block from point A to point B? Suppose the mass of this block is 5 kg. I repeat, what is the work done in moving the block from point A to point B along an inclined plane having an angle of inclination 60 degrees from point A to point B? That's the question. Okay. So how do we even solve this particular question? Anybody? What is the answer for this question? It's quite simple. Anybody would like to try it out? We are applying some a force. Okay, so I'm giving you that also. If force is applied, say the force is equal to 20 newtons. Okay, I'm giving a force. So what would be the work done in calculating work done in pushing the object of 5 kilograms from point A to point B? So work done from A to B. Yes, anybody feel free to answer. In case you know the answer and you're not answering, please feel free
100
to give
newtons, sir.
100 newtons. So why don't you consider the angle here?
Linear, linear angles, sir.
Yeah, both of them are linear. That's correct. Even though I have placed it on an inclined plane, can you see that 5 kilogram block and 5 meters both are along the same direction? Isn't it? The angle between force and the angle between displacement vector or AB is zero, right? So therefore, your answer is going to be 100. Absolutely right. Okay. So here the answer is work done is equal to force into displacement. Force is 20 newtons. Okay. Force is 20 times displacement is 5. 25 is 100 joules is your answer. Straightforward. Now you may ask, can we solve this question by using the angular approach? Yes, you can. How? Still you will get the same answer. You want to see? Work done is equal to force into displacement. Force is nothing but F cos theta into displacement. Now, who can tell me what is the angle theta between force and your displacement? Because both of them are along the same direction. So, what would be the angle theta in this case? Force is 20. Cos theta is going to be 0. Okay, so cos 0 into displacement is going to be 5. I hope you guys know that cos 0 is 1, and again you will end up getting the same answer, which is 100 joules. So there are different ways of solving the question, but still you will get the same answer, which is 100 joules. So there are different ways of solving the question, but still you will get the same answer, which is 100 joules. So let me just give you an example here. Is it clear to all of you? Shall we proceed? Or you have any doubts, you can ask. Okay, I hope everything is clear. Fine. So we'll move on to the next aspect. So this is all about work done, children. Okay, different aspects of work done. As we solve questions, you will see again different models. There are so many models. Fine. I've just given you an idea of how to approach. That's very important. On that, we'll move on to the next part. Okay. Now we'll see work done by a variable force. So we are seeing the next concept for the day. Work done by a variable force. So we'll see how work can be calculated by a variable force. Okay, it's very simple. We go by a calculus approach, nothing else. Okay, so if you want to visualize it, you can visualize. There is a small graph. So we try to understand this using a graph. Along y-axis, you will take force in newtons as a function of displacement. Along x-axis, you have displacement. Okay, displacement is in meters, force is in newtons. Okay, when I say variable force, you can have a curve like this. So between any 2 points, you can find out. So the area of that curve will give you the work done. So say this is point A and this is point B. I want to find out the work done between point A and point B. Point A is the initial point and point B is the final point. Okay. So this is initial point. Let me call it as xi. This is final point. I'll call it as xf. Okay, wherein I and f means initial and final respectively. So here you can find out the work done as W is equal to integration f of x into dx. This is basically integration. It's a calculus term. Okay, I hope you guys might have some idea about calculus or integration or differentiation. So if you have the idea, it will be easy. Otherwise, I'll have to teach you the basics of integration. Okay, so this is the formula for work done by a variable force. All right. So I'll give you an example. Before that, I'll teach you the basics of integration. Okay. Now, integration has got a formula. Say, this is the symbol of integration. So integration of x power n into dx. What is this equal to? Okay, we'll try to understand. This is an integration term. This is called integration symbol. So we call it as integral. So integral means to add up or to sum up, okay, or means to integrate. So integrate is a terminology in English which means to add up or to sum up, okay, or to join or to combine. X power n. This particular term is called as integrand. So integrand is a term which needs to be integrated, okay. The term on which integration is performed, you call that as the integrand. And dx, sometimes you will have dx, or you can have df or dq, whatever it might be. The moment you see d and some letter, that term is called as integrating factor. Okay, so this is called integrating factor. So it is the factor based on which integration is being performed. So these are the three important terms that you will have to know. So what is the formula for integration of x power n into dx? Let's try to understand. The formula is x to the power n plus 1 upon n plus 1. So this is the formula for integration of x power n into dx. Okay, simple children. So this is the formula. So I'll just give you a simple question. You will have an idea. So integration of x square into dx. What will be the answer for this? If I would like to integrate x square into dx, then the answer would be x to the power n plus 1. Here, remember, n is 2. The power of x is n. So 2 plus 1 is 3. So answer is x cube upon 3. It's as simple as that. Okay. I'll give you another question. What is the answer for integration of x to the power 4 into dx? The answer would be x to the power 4 plus 1, which is 5, x power 5 upon 5. Simple. Then what's the answer of integration of 6x cube dx? How do I do this? Here, 6 is constant. You can take it out. You can write this as 6 integration of x cube into dx, whose answer would be 6 times x to the power n plus 1. Again, applying the formula, you get 6 times x power 4 upon 4. You can further simplify this and write it as 3x power 4 upon 2. Okay, that's it, children. So that's how you would integrate. Okay, I hope that's clear. So work done by a variable force is given by the formula work done W is equal to integration of f of x into dx. Here we also apply the limits. Limits can be from the initial point xi to the final point xf. So this is called as the limits from initial point to the final point. These are called as limits of integration. Now we are going a step higher. So let's try to integrate with limits. Then what happens? Again, let us see the examples that we saw. What is integration of x square into dx if I'm applying the limits from 2 to 4? Let us carefully, understand. So pay attention. Integration of x square. First, you just integrate. Just forget about the limits. If you just integrate, what's the answer for this? It is x to the power 2 plus 1, which is x cubed divided by 3. That's it. Now you put a square bracket and you have the limits from 2 to 4. 2 is called lower limit and 4 is called as the upper limit. I repeat, 2 is called the lower limit and 4 is called the upper limit. The constant terms can be taken out of the limit, which means 1 by 3 can be extracted out. I retain x cubed inside, again having the limits from 2 to 4. Now let us apply the limits. So the answer is 1 by 3 within brackets. In the place of x cube, you will apply the upper limit. Okay. So what is the upper limit? The upper limit is 4. So the answer is 4 cube minus 2 cube. You do upper limit minus lower limit and then you evaluate. Okay. So in this step, you need to understand you have to do upper limit minus lower limit. Okay, that's the procedure to apply the limits. And what's your final answer? It's 4 cube minus 2 cube. Okay, so how can we even write this? Anybody? Can be expressed as 1 by 3. You can simplify this. I hope if you guys know the exponential method of writing it, you can go with exponential method of writing. Okay, that's also fine. So 4 cube, 4 can be written as 2 squared also. You can also do it that way. I mean, it is up to you. So you can also write it that way. Okay, and then you can take 2 cube as also a common out. Otherwise, directly you substitute and then you can simplify. Okay, so 4 cube can be written as 4 can be written as 2 square the whole cube. You can write it like this. All right, so it can be done like this also. Then you can simplify it. So 2 square the whole cube minus 2 cube. And then you can simplify it. 2 square is, generally, 4. So you can also swap the terms. Why I'm saying this? It's easy for calculation. You can also write it as 2 cube the whole square. Both are correct. So 2 cube is 8. 8 square is 16, right? So you can go for simplifying it. Simplify. Okay. So 2 cube is 8. 8 8s are 64. So 1 upon 3 times 64 minus 2 cube is 8. So 64 minus 8. And then you simplify it, children. So you will be getting the answer. So the different ways of doing it. So whichever way you feel is easy, you can simplify in that particular method. So you will get 56 upon 3. Okay. Which is 18.6. And that's your answer. All right. So that's the method to apply integration with limits. So this is an important calculus, method. So which you have to remember. There are questions which are asked based on calculus approach. So it's good to learn this calculus method. Okay. So on that we will move on. Let's move further. Now let us see a question based on this. Okay. So here comes a question. Okay. A variable force I repeat, a variable force of 2x cube plus 3x minus 8 is applied on an object to displace it from 3 meters to 5 meters respectively. Okay, so you should calculate the work done. Question is calculate work done. So how will you solve this particular question? Okay, first substitute in the formula. Coming to the formula, work done by a variable force is given by integration from initial point xi to xf f of x into dx. Okay, so here they have given you the function of force. Okay, force as a function of x is already given here. Go and substitute it. So you will get integration. What are your limits, children? Your displacement, you can see it is from 3 to 5 meters. So the limits are from 3 to 5. F of x is given as 2x cube plus 3x. 2x cube plus 3x. Okay. Minus 8 into dx. So see here, I have substituted. And you have to now integrate. Go for integration. Each and every term to be integrated. Okay. So first you will integrate 2x cube. So you can take 2 out, constants out, and just integrate the x terms. Wherever you find x, only that you will integrate. Okay. So that's it. Here also it is 8 into dx, so that you should integrate. So 2 times integration from 3 to 5 x cube into dx. You remember this dx is common for each and every term. Okay, x cube into dx. Plus, next 3 can be taken out. So 3 times integration from 3 to 5 x into dx. And then I have a minus sign, 8 integration of just dx. Okay, again from 3 to 5. As simple as this. So this is how you will do it in parts. Separately you will substitute. Then go for a simplification. 2, what is integration of x cube? Apply the formula x power n plus 1 upon n plus 1, which will give you x power 4 upon 4. Okay, and you'll have to apply the limits for the x term, which is from 3 to 5. Plus 3 times integration of x. Okay, into dx. So x is just, the power is just 1. If there's nothing, the power is 1. So 1 plus 1 is x square, right? So it is x square divided by 2. Again, your limits are from 3 to 5. Minus 8. You don't have anything. You just have 1 into dx. Integration of 1 into dx is x, children, remember. So x limits are from 3 to 5. Simplify it. 2 and 4 you can cancel. 2 ones are 2 twos are, right? So it's 1 by 2, which is 0.5. Okay. Times x power 4. Limits from 3 to 5. I'm applying the limits here itself. So it is upper limit. So 5 to the power 4 minus 3 to the power 4. Plus 3 by 2 is 1.5 times x square. So you substitute in the place of x first 5. So 5 square minus 3 square. Okay, upper limit minus lower limit. Minus 8, again opening the bracket, 5 minus 3. Directly you can evaluate, which is 2. Simplify it. Okay, simplify it by whatever technique you would like to. You just need to simplify this. This is the method, children. I'm just giving you the idea of how you will have to proceed and how you will have to solve, such questions come. Okay, so this is a method to solve such type of questions, if they happen to appear. So again, I hope 5 power 4. Try to simplify. 5 5 is 25. Again, 5 5 is 25. 25 times 25 is 625. I hope you will get 625. So 0.5 times 625 minus 3 power 4. I hope it's 81. Okay, plus 1.5 times 5 square is 10. 5 square is 25 minus 9, which is 16. Minus 8 twos are 16. Okay, simplify it. 25 minus 81, which is 544 into 0.5, which is by 2, plus 3 by 2 and 16 I can cancel, that's better. 8s are minus 16. Okay, so 544 children divided by 2, I hope you'll get 272, plus 3 8s are 24, minus 16. And what's the answer? Minus 16. So 280, I guess, right? 272 plus 24 minus 16. 280. So that's the answer. 280 joules is the answer. Okay, so the work done is 280 joules. So work done by the variable force, which was given as a function of x or displacement, is 280 joules. Okay, so that's how you do it. So this is the method to solve questions based on work done by variable force. Okay, so as we go deeper and deeper, we will be looking at tougher concepts. So each and every aspect, as in when I'm introducing the concept, it's a good habit that if you have a notebook, if you're jotting it down, the concept, so it's good so that you'll not forget. Okay, rather than just listening. All right. I hope you guys are understanding, but it's a good habit, to jot down the important concepts, the formulas. As I'm solving, if you're solving with me, very, very well, it's great if you're able to do that. Okay. So I hope all of you are traveling with me so far. So hoping so. On that note, we'll continue. So we are done with work done by a variable force. Okay. Now we are moving on to the next concept, children. This is also a crucial concept. Now we are going to see the work done by a spring. Okay. So we can have a spring system as well. So now we are going to find out what is the work done by a spring. Okay. So when you apply force on a particular spring system, then what is the work done? It's very similar. So work done is equal to minus half into k x naught square. This is the formula for work done by a spring. Okay. So this is a general formula. You also have the integration formula, which is given as integration from zero is initial position, to some position x naught. Okay, 0 to x naught minus kx into dx. So this is the formula for work done by a spring. Because whenever you compress a spring, the spring will, there is a restoring force that is, present in the spring, the elastic potential energy we say. So when you compress it, it will try to come back to its original shape and size when you release it, right? So the force is acting against you. That's the reason there is a negative sign here. So F is equal to minus kx is called the formula for force of a spring. Okay, so F is equal to minus kx. So that's the relation that is being used here. So you go and substitute it, you will get this negative kx term. That's how it came in the first place. So this is the work done by a spring. Okay, the negative force indicates that the spring is doing is also applying force in the opposite direction when work is being done. Okay, so force is applied by the spring in the opposite direction of work done. That's the reason you take negative sign convention. Okay, so that's the understanding here. So that's all about work done by a spring. Again, we have different questions. We will see that. Okay, one by one we will see later on. So now we will move on to the next concept without further delay. Next, we have kinetic energy. I hope this term is not new to you guys. Definitely, you would have encountered the term kinetic energy at least one point in your lifetime. Okay, so what do you mean by kinetic energy? Does anybody have any idea about what kinetic energy is? If you know what's kinetic energy, please feel free to communicate. You can tell me what you understand by the term kinetic energy from what you have learned. I hope it's not new. Yes, children, nobody has heard about what kinetic energy is.
1 by 2 mv square, sir.
1 by 2 mv square, correct. What is definition of kinetic energy? What does it literally mean? Half mv square is absolutely right. But what it is? Kinetic energy is the energy possessed by an object when it is in motion. When an object is in motion or it's moving, you say that there is kinetic energy. Okay, that's important. So that's the basic, definition of kinetic energy. As you said, formula is important. So kinetic energy is given by the formula half mv square. Here, m is mass in kilograms and v is velocity in meters per second. Okay, so kinetic energy is the energy possessed by an object when it is in motion. So I'm writing it here for your understanding. Energy possessed by an object due to its motion. Okay, due to its motion, you call it as kinetic energy. Okay. Next, then what is potential energy? We are going to the next category. How is this different from the previous? Anybody? Is it same or is it different from kinetic energy? Feel free to unmute and speak.
Due to its rest, sir.
Very good. Potential energy is the energy possessed by an object due to its rest, but depends on its position, okay, or configuration, where it is kept. So an object at a certain height will have a greater potential energy. Okay. Suppose I'm in the ground floor and my friend is on the fifth floor. So who would have greater kind of potential energy, me or my friend? The answer is my friend. Why? Because he is on the fifth floor. He is at a higher altitude. He is at a greater height. So, what does height have to do with potential energy? Yes, potential energy increases if height increases. So, passengers on an airplane which is flying at a height of 45,000 feet will have a
mgh,
greater
sir.
potential energy. Perfect, that's correct. The formula is mgh. Okay. So we'll see the formula also. So potential energy is equal to mgh. Here you have an additional term called G. I hope you guys might be knowing what G is. Okay. So potential energy, I'll just write it here. It is energy due to position of an object. Okay, due to the position of any particular object. M is mass in kilograms. G is acceleration due to gravity. The exact value is 9.86, but approximately for easier calculations, we take it as 10. Okay, so this is all about, and h is the height. So this is potential energy. Next, we are moving on to the next one, which is mechanical energy. What is mechanical energy? Anybody heard about this? How is it even different from the other two? What do you mean by mechanical energy? Okay. Mechanical energy is the energy, the sum of the kinetic and potential energy, sometimes also referred as total energy. Okay. So mechanical energy means it is a sum of kinetic and potential energies. So that is mechanical energy. And what is its formula then? It is half mv squared plus mgh. You can also go take a common out. To take a common out, what happens? You can write it as m times v squared by 2 plus gh. You can also go for an LCM, which will give you m times v square plus 2gh, the whole divided by 2. Okay, so that's the formula for mechanical energy. Me. I'm writing it as Me. Don't confuse it for mechanical engineering. It is mechanical energy here. All right. So this is all about it. So we have understood what's kinetic energy, potential, and mechanical energy, and what are their formulas. Okay. So we have discussed all this so far. So these are all about energies, children. I hope this is clear. So far, so good. So on that note, we will proceed further. Okay. So then we have even other types also. So we are going to see the next aspect, which is gravitational potential energy. The next category, let's write it here. We have something called gravitational potential energy. So we try to understand what is this. What is meant by gravitational potential energy? Okay. So it is the energy associated with objects separated by distance r from the surface of the earth. So we call that as gravitational potential energy because Earth's gravity is always pulling the objects towards the surface. That's the reason it's called gravitational potential energy. So it is given by the formula, children. U is equal to minus G times M1 into M2 upon R. So that's the formula for gravitational potential energy. This is the formula. So here G is called as universal gravitational constant. Okay, it's a constant value. I'll give you the value also. It is 6.67 into 10 raised to minus 11. Okay, units are Newton meter square upon kilogram square. So that's the value of universal gravitational constant. M and M2 are masses in kilograms and R is the distance in meters. Okay, that's it. So this is all about gravitational potential energy and its formula. Okay, so this is something that you should know, children. Okay, and then we'll move on to the formula for power. Okay, next we have power. So power is defined as the rate of doing work. We can say work done upon time can be called as power. Okay, so the definition of power is the rate of doing work. It is defined as rate of doing. The rate of doing work is called as power. So you go and substitute the formula. You know, work done is equal to force into displacement upon time. So don't you think displacement by time can be replaced by velocity? So you can write power as force into velocity also. Force can also be written as mass into acceleration. So you can write it as MAV. So power has got different formulas. What are they? Power can be written as work done upon time or force into velocity or mass acceleration times velocity. So these are all the possibilities or the formulas for power. That's it. Okay. What is the SI unit of power? The SI unit of power is called
But
watt. Very good. Watts. Okay. WATT, which is singular. In plural, we call it as watts. So that's all about the power. Okay. So I hope that aspect is clear, children. That we move on. So I hope you have made a note of all these formulas. So we have completed all the concepts of this particular chapter, work, energy, and power. So these are all the important concepts that we have seen. Okay. So now we can solve all the questions. So let us do questions now. Let us see questions based on Neat point of view and GE point of view as well. So let me give you some questions. Okay, here comes the first question. You just write it here. First question. A bucket of water weighs 10 kilograms. A bucket of water weighs 10 kilograms. It is pulled from a well 10 meters deep. It is pulled from a well 10 meters deep. Okay. Water from the bucket water from the bucket escapes through a small hole at the rate of small hole at the rate of 0.2 kilogram per meter. Okay, per meter. Find the total work done in pulling out the bucket from the well. The question is, find the total work done in pulling out the bucket from the well. Okay, in pulling out the bucket from the well. We'll give you the options. Option A, 200 joules. Option B, 300 joules. Option C, 900 joules. And option D, 600 joules. These are the options. You can try it, take your time, solve, and you can tell me the answer. So quickly grab a notebook and then solve it, children, and tell me what's the answer for this question. Try it out, children. Please work it out. Only then you will get it. You have to solve it. You cannot guess the answer. This question was asked in AIMS 2022. AIIMS. Any idea how to solve it? I hope you guys are trying it out. So have you guys tried? I just gave you time to try it. So I hope you guys were trying it. The answer is 900. Very good. That's right. Okay, the answer is 900. Perfect. So finally, one of you have given the answer. So that's correct, children. That's the answer. Okay, for those who didn't get it, I'll tell you what is the method to solve this question. Don't worry. Here, you can see that initial mass of the water in the bucket is being given as 10 kilograms, right? So that's given as 10. So the amount of water that is being escaping is 0.2 kilograms per meter. That is what is given, provided it is being pulled, So for every meter which is it is being pulled up, zero point 0.2 kilograms of water is being lost from that hole. I mean, it's escaping from that hole. That's the mean. Okay. So here, when you're applying the formula for work done, you will apply the formula as work done. Now here, the force, work done by a variable force is what needs to be applied here. From the bottom of the well, only you are pulling the bucket. So work done is integration from 0 to 10. You will apply the limits. Okay. Because it is going to be at a distance of 10 meters, I suppose, right? So 10 meters deep. 0 is the lowest, bottommost point of the well. So 0 to 10 meters. So within bracket 10 minus 0.2x. So we take it by a variable because 0.2 kilogram per meter, they're saying. So that's the variable factor. So 0.2 x times g into dx. So here the formula F is equal to m into g is being applied. That's the reason it is g into dx. That's it, children. So this is what we are doing. You substitute this, you simplify it, okay, and apply the limits. You get the answer as 900 joules. Okay, and that's how you solve this question. So this is the method, this is the approach to solve this question. I hope you guys have an idea of how to approach questions like these. Okay, so try them. I'll be posting these notes also in the WhatsApp group. Sir will be posting it. I'll be sending it to him. So you will be getting all this. Please practice it. Okay, on a daily basis, you practice. You will not lose touch. That's very important. Not just before the exams. On a daily basis, please revise the concepts and go through the formulas, which will definitely have you will definitely have an edge on the other people who are giving the exams. So you have to have a constant touch on the formulas and the concepts. Otherwise, things might be much difficult. All right. So on that note, we can wind up, children. Any doubts you can definitely ask. The class is open for doubt clarification. Otherwise, we can wind up. All right, and we can meet in the next lecture positively. Fine. So any doubts you can ask, children. Otherwise, we can wrap up the session. Yeah. Any doubts you can ask. Okay. So I think it's clear to all of you. All right. So thank you, children. It's again, yeah. Welcome, Tamil Selvan. So it's great to have all of you on board again, and I appreciate your patience. So thank you, and we'll meet once again in another interesting lecture in physics at in igniting young minds. So until then, bye byes. Good night. Take care. Yeah, welcome.